Alright, ladies and gentlemen, we're going to be working on lesson 5-6. This is on page 183. Again, you're on page 183. Today we're going to be focusing on use properties to multiply by 7 and 9. So, let's read what it asks. Is it always true? A 7's fact can always be decomposed into 5s and 2s. So can you break it down? A 7's fact and always break it down to 5s and 2s. The answer is correct. Let's go on over here. We'll flip the page. So now we're on page 184. Dustin places 9 books on each of 7 shelves. How can you find the total number of books he placed on the shelf? So he's going to be multiplying 9 times 7. He's going to decompose 7. That means break it apart into 5 and 2. So then you're going to have 5 times 9, and you're going to have 2 times 9. So you're going to use your partial products to add them together to get your product of 63. So 7 times 9 equals 63. The same thing goes, we can take 7 and decompose our 9 into 5 and 4. So we're breaking apart and pulling out that 5. So you can decompose to find products of 7's and the 9's facts by pulling out the 5's. Let's look down here at the bottom. I'm going to read it to you. It says, let's fix the focus on that a little bit. There we go. Carly hangs 9 photos in each of 6 rows on the wall. Not the hall, the wall. How can you decompose 9 to find the number of photos she hangs? Alright, so let's make sense of it. She hangs 9 photos in each of her 6 rows. So if this is one row, then she's got 9 photos. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would mean she would have 2 rows and she'd have 9 photos there too. And you would have to do that 6 times. So this is me making sense in my head. So if I got 9 times 6 equals my unknown, which I'm going to put A for answer. How can you decompose 9 to find, so we got to break apart our 9. So I'm going to decompose my 9. I'm going to take a 5 out. So 5 times 6 plus what's left, 4. So 4 times 6. Then I find my partial products, which 5 times 6 is 30, plus 4 times 6 is 24. So it's 54. Now, I don't know hold on, what's my unit? How can you decompose? So we did that decomposing. We got to the answer. So 54 total photos. Is what we would have. Now we're going to move on over to page 185. And we're going to have the top. You're going to have to tell me, let's see, this one, you're going to be telling me what the product is. Product, factor, 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 product, product, factor, and product. Remember, product is the answer to a multiplication problem. You have 2 factors that you multiply together in a multiplication problem. So I've got to do 7 times 9. Well, I can break it down and say, well, I know it's 7 times 5 plus 7 times 4 if I want to, because I decompose the 9. Then I have 35 and 28. And when I add those two together, I get 63.
So my product is 63. Now I can decompose this by decomposing my 6. 9 times 5 plus 9 times 1. So then I've got 45, and I've got 9. And I add those together, I'm going to get 54. And I got blank times 9 equals 18. Well, I know if I double my 9, I'm going to get 18, so that's a 2. Now look, the equal sign means we're balanced. This side has 7 times something, this side has 7 times something. So our other something has to be what's on the other side. They just flipped it around, didn't they? They used commutative property. Alright, well, I know that 2 sevens is 14, and 3 sevens is 21. 7 times 7, oh, that's a doubles fact. 7 times 7, I can decompose it to 7 times 5 plus 7 times 2. Then I got 14 and 35, which is 49. 9 times 9. I just know my double facts, and it's 81, but I could break it down to 9 times 5 plus 9 times 4. Oh, look, there's another equal sign, and it's balanced. So I've got 10 on this side being multiplied and 10 on this side, so therefore I have to have 9 on the other side. Oh, 8 times 7. I can break it down and go 8 times 5 is one part, plus 8 times 2, which is the other part, so I got 16 and 40. When I add those two partial products together, I get 56. Good job. Alright, 10. Alex arranges his rock collection in 9 rows with 4 rocks in each row. How can you use the 5 facts to find out how many rocks Alex has in all? It's my first time reading it, so now I'm going to read it again. Alex arranges his rock collection in 9 rows. So I know I have 9 rows. So 1, 2, 3, 4, 5, 6, 8, 9 rows with 4 rocks in each one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I know this is going to go all the way down. How can you use the 5 facts to help you? Well, my 5 facts, I could do this right here, and that's a 5 fact, isn't it? Oh, I see 2 different ways that we could do this. We could do, so say it's 9 times 4, right? So we can break this down. We can go 5 times 4 plus 4 times 4. So that's 16 and that's 20. We add them together, we get 36. But we can also do, well, yes, it would be a 5 fact. But you do 5 times 5 and 5 times 5 and then subtract 1, but that's going to be more difficult. This is probably the way that I would go. How can you use the 5 facts to find out how many rocks Alex has in all? So 36 rocks in all. And this is my proof on how I explain it. Looking at number 11. Lula's mother buys 7 packs of smoothies. Each pack has 6 smoothie bottles. How can you use a 5 facts to help you find how many smoothies she buys in all? So that's the first time reading it. Lula's mother buys 7 packs of smoothies. Each pack has 6 smoothie bottles. So if this pack and it had 6 smoothie bottles. So this pack have 6, and I would need 7 packs, right? So there's 6 and there's 7. Alright, so we know that it's going to be 7 times 6. And guys, I made you do this so much, I know you know exactly what the answer is already. but it says how can you use 5 facts. So you have to decompose it with the 5 facts. So you can do 7 times 5 plus 7 times 1, and then get 35, and then 7, which is going to give you 42 total smoothies. Alright, flip that page over. Got number 12 here. Tony knows his 4s and 5 facts well. How can he use properties of multiplication to find the product of 7 times 4 and 9 times 5? Explain your thinking. So they're wanting 2 different ones. So I'm going to do 7 times 4 over here. I'm going to do 9 times 5 over here. I'm going to read it because I always read it twice. Tony knows his 4s and his 5 facts well. How can he use the properties of multiplication? Now remember, we've talked about properties of multiplication. Property of 0, property of 1, property of 6, property of 4, properties of 2. We've got all kinds of properties that we've learned. To find the product of 7 times 4 and 9 times 5. Explain your thinking. Well, if he knows his 4s and he knows his 5s. Well, if he knows his 4s, he should know this one. And he should know this one. But we're going to break it down to help him more. So I'm going to decompose the 7 to 5 times 4 plus, then the 2 is going to come out, 2 times 4, and then I have 8 and 20, so therefore my 2 partial products is 8 and 20, and I add those together to get the product of 28. And we don't have a unit, do we? He's just doing a multiplication equation, so there's nothing I can write after 28. Alright, then I'm going to decompose my 9 to bring a 5 out of it. 5 times 5 plus, oh, almost messed up, 4 times 5, because I broke down my 9, which is 5 and 4. 5 times 5 is 25, plus 5 times 4 is 20. There's my 2 partial products. I add those 2 together and I get 45. Explain your thinking. Well, I could go into deeper, but this is explaining, breaking it down, but I could use some of our math vocabulary words that we use. I can explain by, I could decompose 7 to 5 and 2, period. Also, 9 can be 5 and 4. Be careful. I don't like how close I got to that number, because it can be skewed. It can be messed up. Now, I just used the word decompose there. Now, if I had more room, I could even use the word, equation. I can use the word partial products, because these are partial of the product to get to the product. So I could use those different vocabulary words in explaining. Let's look at 13. There are 7 rows of desks in Gracie's computer lab. Each row has 5 desks. Draw an array to represent her computer lab, and then decompose one of the factors to find the total number of desks in the lab. Now this is long, so I'm going to read it again. There are 7 rows of desks in Gracie's computer lab. So if there's 7 rows, that means there's 1, 2, 4, 5, 6, 7. Each row has 5 desks. Okay, so I know I'm going to have 5. 1, 2, 3, 4, 5. Draw an array, so we're going to have to complete the array this time, to represent her computer lab. So there's 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Make sure you're making circles and not dots because the dots get confusing. Make circles. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 7 rows, 5 in each one. This is an array to represent the computer lab. And then decompose one of the factors to find out the total number of desks in the lab. So I know I had to do 7 times 5. And if I'm going to decompose, I'm going to break apart my 7. So that means I'm going to take a 5 out. And since it's 7 is my factor, then I'm going to use 2 to complete my factor of 7. I'm going to keep my 5s the same. So 5 times 5 is 25. That's a partial product. 10 is my other partial product. When I add them together, I'm going to get 35 as my product. Total number of desks. So 35 total desk. Now we're going to go into extended thinking. Ava has 10 packages of erasers. Each pack has 6 erasers. She gives 1 pack of erasers to a friend. How many erasers does Ava have left? Show each step. Okay, so Ava has 10 packs of erasers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each pack has 6 erasers. So 6, 6, 6, 6, 6, 6, 6, and 6, and another 6, and another 6. She gives 1 pack of erasers to a friend. So this is gone. She give it to a friend. How many erasers does Ava have left? Okay, so now let's think about the equation that we would have written. We could write there's a couple of different ways to write this. I could write 10 packs minus 1 pack, and I need to do that first, times 6 equals my answer. So anything in the parentheses gets done first, so I know that's 9, times 6 equals my answer. And then I can break this apart to 5 times 6 plus 4 times 6, 24, and 30. So it's 54. 54 erasers. But you know what? I know that there's 6 in each pack, so I could actually do another way too. I could do 10 times 6 and then subtract 6. So if I do this way, I'm going to get 60, and then I'm going to take 6 away, and I get 54 erasers. So there's 2 different ways to do that. Alright, ladies and gentlemen, you're going to tear this out. You're going to tear out all the way back to page 183. You're going to staple it to the work plan.